Right? When you have given information, again, I would label what you have. Okay, so we know that A, B, and C, D are parallel to each other. You know the B, C, D, and B, E, F. Okay, so here's B, C, D, and here's B, E, F. Okay, so those are supplementary. And usually when you're looking at proofs, the information that they provide will usually be used. It's not going to be a whole lot of times where they give you information that's not used. Okay, so let's take a look at what we're asked to end with, the statement we're looking to find. We're looking to find that BC and EF are parallel to each other. So what ways do we have to show that?
You could make angle ABC supplementary to angle BCD.
Okay, good. So in order for us to have these two lines parallel, we need to find one of those four patterns, right? AIA, AEA, CA, or SSI. And now the fact that all we're left with is one angle right here means that we either need to use these two angles and use SSI, we need to use these two angles and use CA, or we need to use these two angles and use AIA. And so that's kind of, when you think through your proofs, you want to try to build backwards a little bit. Okay? So what Brendan suggested is, let's get another statement that's in a form very similar to this. Okay? So since these two lines are parallel, we know that these same side interior angles right here and here, so angle ABC and angle BCD do equal 180. And the reason we know that is, since lines are parallel, same side interior angles are supplementary. So SSI is the justification for that. Okay. Now, many people or many students will look at this and say these two statements are nearly identical, right? The only difference is ABC and BEF. Okay. So you know that ABC and BEF are equal to each other. However, logically, we have to demonstrate that step by step. You can't just jump to that conclusion. So what we're going to need to do here is build up the case, kind of argue why that's true. So right now what we do see is we have two things, this whole expression and this whole expression. They're equal to the same thing, therefore what do we know about them? They're equal to each other. So we could say measure of angle BCD plus angle BEF is equal to measure of angle ABC plus measure of angle BCD. And we know that because of what? Two things equal to the same thing are equal to each other. Transitive property or substitution. Okay, so now we can continue working with this statement. What can we do to both sides to get the relationship that we had already identified? If we just remove the same, remove equals from equals, we're left with angle BEF is equal to angle ABC. And so we just subtracted the same value from both sides. So now if we look up here, we have BEF is now equal to ABC. What kind of angles are those? Corresponding angles. And if corresponding angles are equal, what do you know about the lines? They're parallel. So we can now make our final statement. BC is parallel to EF. And the reason for that, based on what we chose, is CA.